Code versus software engineering. Code is like the number 37, and software engineering is when you program stuff. All right, this was a good talk. I guess I'll talk to you guys later, and see you next Monday. Now, this is going to be definitely a very enlightening talk about how deep you can go, because it's a lot more complicated than that. And in casual conversation, whenever you say, I am a coder, or this is a code, or I write code, or whatever the case is, it's going to be something different than software engineering, and there's a whole lot of stuff in between. So feel free to jump in the conversation. We talk about these videos before and after. We have a lot of talks in the guild channels, in the user group SEA channels in Techlahoma. So jump in those conversations. Feel free to ping me. And I'm happy to talk with anybody about any of these things, even in the future. So if one of these definitions of like what is code, for example, if something comes up in your mind, feel free to ask here inside of the chat, but also feel free to jump inside the chat afterward and talk about it, because if there's enough consensus that we need to add an exception or specifically include something, or whatever the case is, then we can remake this video. We can redo a talk with new information. We're a community, and we need to come together and find this ubiquitous language. So this ubiquitous language, just to be clear, is nothing about this talk is dictating what the whole entire industry in the world has to do. Ubiquitous language, first of all, means using the same terminology everywhere. In this case, everywhere is everywhere where I do a talk, or the guild does a talk, or anything related to user group SEA. We want to make sure that we're using the same terms. We're all on the same page. So Eric Evans coined the term ubiquitous language in the world of software engineering when he wrote his book for domain-driven design. And I use it a lot just to use it as we're all speaking the same language. So terms used in the guild and user group SEA. This is not dictating to everyone, but whenever you're watching these videos, or if you want to adopt these as your official usages of these terms, then feel free. I highly encourage that. Now, hiring. So this is sort of the crux of the talk. I'm going to start off with this before I get into like what is a code. So looking for a novice or a hobbyist brain surgeon. We just want some minor tweaks to our prefrontal cortex. No big deal. So we just want someone with 2 years of experience being hobbyist inside your garage, or whatever the case is, learning brain surgery online, and a mastery of techniques doing craniectomies. So imagine that 60 is fairly low for a surgeon, but maybe average for like a physician or something like that. This is sort of the crux of the problem that we're getting at, is that these are all words and they all make sense and they can be put together, but this is going to not end well for whoever it is that's doing the work, or whoever it is that's receiving the result of this work. One of the main points is, if you're a brain surgeon, you're not a novice. There's no such thing as a novice brain surgeon. There's no such thing as a hobbyist brain surgeon. So a brain surgeon, just using that as the idea of, first you go to school, you get a little bit of experience, you become an intern, you go through the ranks. Once you're a brain surgeon, you've gone through so much education, have so much experience, that you're not a novice. I'm going to talk more about this and the implications of saying something like 2 years of experience in relation to something that probably requires 10 years of experience to become, and all that sort of stuff toward the end. But this is sort of the crux of why we need to come up with this ubiquitous language, at least in official capacity. During casual conversation, if you're getting brain surgery, you might say, I'm going to go to the doctor. I have a doctor's appointment, next week. I'll be out for a week, or whatever the case is, a month, I don't know. I'm going to go to the doctor. We all can say whatever we want in casual conversation, but if we're talking about in official capacity, we want to have these same terms that we're using with each other. So what are codes? A code is information. It's just little bits of information that is easier for a computer to interpret. So we have human readable information. Of course, that's subjective. Everything human readable is subjective. But then we have computer readable information. So these are codes. This exact date format with these numbers, that's a code. California is a code, like a category code or a key code or something like that. These are all codes, things that are standardized, that the computer knows how to look for this information. These are keys, these are key codes, or just codes. Codes are bits of information that the computer knows how to understand. It's super, super high level. I mean, if you're coming from a background of saying, I'm a software engineer, I'm a programmer, and you know what code is. Code is if this, then that. That's code. But we're really boiling it down to what are codes, and codes are things that the computer can understand. So interpretation, I did say back on that last slide, it's codes are things that the computer can interpret. An interpreter is a compiled program, and the goal is to use the raw codes as instructions. So an interpreter, usually you don't compile the codes, but an interpreter takes those codes and it uses them as instructions. I'm not talking about an interpreter when I say that a computer can interpret codes. I am talking about, it could be an interpreter, but I'm more so talking about that the computer can understand it. So translating codes into their own compiled program, but also including a computer can read codes to analyze coded or encoded data. So if you're inputting codes to Excel or whatever the case is, then the computer can understand those. It can do sums, it can do concatenation, it can group by, it can do things that it can understand for codes. So in software engineering and architecture, that's what I mean when I say SEA, software engineering and architecture. What is coding? So not just the super high level, what are codes, but what is coding? So coding, I made this bold here, where a human converts non-coded information, such as make this bold and this italic, this is non-coded information, and the human converts it into a coded format that the computer can interpret. So add two numbers and give me the sum, and then a human puts these codes with these symbols into the system, and the computer can interpret this, it can compile it, it can do whatever it wants to do with it, but it understands this. If you just write this into a computer, depending on which computer you write it into, then maybe it wouldn't work. But taking these are codes right here. This is, again, this could be human readable, obviously. I can read both of these things, but the computer understands these better than it understands these. And the key word here is a human. A human does coding. So what is not coding? All these things, a human uses a computer. Let me go ahead and also throw a corner cam up here. A human uses a computer, and that doesn't necessarily mean they're coding. Because if I'm a human and I am playing Minecraft and I put a block down on the ground for Minecraft, there's a lot of codes that are being stored, but the computer is generating those codes. It knows based on in your UI, you clicked on a thing, it knows you placed a block there, so then it takes the codes, the coordinates, and all that sort of stuff, and it says we're going to save this in memory. And typing non-coded information into a spreadsheet. So just because you're using a spreadsheet or an IDE for programming, for that matter, just because you're using one of those doesn't mean you're necessarily coding. Because as an accountant, I might be putting in categories, which are codes. I might be putting in categories, putting in numbers, and all these things that the computer can understand. And we got this field called description, and the accountant might send this back to whoever they're doing the accounting for and say, fill in the description. So someone opens up the spreadsheet and they type in, this is when I went traveling and I had to get gas, or whatever the case is. And then it needs to go back to the accountant, and they will code that. They will say, okay, this goes in the gas category. This is going to be, however they're going to do tax codes. So just because you are using a computer and you are doing things doesn't necessarily mean that you're coding or a coder. So let's talk about what is encoding. Encoding is pretty much the same thing, but it's from a computer perspective. So it's a bit more complex. A human can do the same types of things and algorithms that happens in encoding manually with an abacus or whatever it is that they want to be doing with the algorithms. But usually something non-encoded, like the human using a browser. So you're using a browser, you go to a website, you get your URL, and you send the URL to your friends, whatever the case is. But encoded means you can give the URL to a computer. The computer is going to take that and turn it into a QR code. And that QR code is a type of encoding. A human technically could create a QR code manually, graph paper, fill in the things, whatever the case is. That's possible, but the algorithms for creating QR codes are fairly complicated to be doing by hand. So yeah, encoding is the same thing as coding. It's taking information and turning it into something that a computer can understand, like a QR code. But it's more complex, and it's something that a computer would be doing instead of a human would be doing that. Something more complex is using a codec, for example. So a video, a human's using the UI when they're creating videos. They're editing videos. They split pieces up. They put pieces together. All the stuff that you're going to be doing, layering in a video. That doesn't mean the human is coding anything. They're just using a UI. They're just using a software. But at the end, the algorithms that the computer uses to compile all that information is they're using a codec to encode it. So coding and encoding, slightly different things. This is just sort of additional information. I don't think knowing the difference between those is the super most important thing. I'm more so just getting into what is coding, is really just getting into the complexities of what is coding. And feel free to ask questions or say anything in the chat. There is like a 20-second delay, which means 20 seconds to me and then 20 seconds back to you. But I will get questions if you guys happen to have any questions in there. Decoding, I don't want to spend a lot of time on this. It's just the opposite. It's just taking information that the computer can understand, and then they turn it into some sort of stuff that a human or some other reading thing is going to understand. Maybe some other computer is going to understand, or whatever the case is. So again, it's very subjective, whatever a human can understand. But decoding means taking it from something that a computer can understand, the system that is using it, and translating it into back into its original form for the most part. Encrypting, so coding and encoding versus encrypting, it's the same thing. Encrypting is a type of coding, or a type of encoding usually. Coding and encoding are they use algorithms to convert something from one form to another. Encrypting does the same thing, but the algorithm isn't public, or the algorithm is probably well known, because there's not too many different algorithms for encrypting. There's some really good ones out there that a lot of people reuse over and over again. But the main difference is the secret key. So the which algorithm they used could be kept secret. You don't just tell everyone which algorithm that you're using in order to encrypt something, but also you're adding a secret key. But it's still a type of encoding. So encrypting is just sort of a different level of encoding, where you're adding a secret bit of information. And then decrypting is the opposite of that, where you need that secret information to decode it. Okay, who is a coder? We're gonna move closer and closer to building software, starting from these super low levels and then building up to build software. So a coder is any person who does coding, and that's pretty much the end of that. But let's not just think about building software, because we have data entry specialists who aren't just entering raw data, but they're coding it. They're taking the information that they know and they're changing it into their brain using a little algorithm, like, okay, I understand this based on this other information, and I need to change it to this sort of key. So data entry, coding things, web developer doing HTML and CSS, obviously coding things, and a software engineer who's writing codes that get translated and compiled into applications. So these are all things that are coding. And what is development? This is just the high-level generic idea of development. So development means you take ideas and plans and you develop it, and you develop it, and you develop it. You can think of developing a photograph. You just sort of take the raw image and you change it, add different colors to it, and you get something else. You take some sort of plan and you develop it through the system. Because generally speaking, development doesn't mean somebody's creating software. It could mean the designer is developing the logo for something. So they take these ideas, take all these plans, they make these different iterations of an image. Development means you're just sort of moving a plan along for the most part. What is UI development? And we could also include web development in there. So the act of taking designed plans, usually taking a design, a wireframe, or whatever the case is, and coding. So we're talking about UI development right now. We're not talking about the design portion of it. We're talking about the coding portion of it. So you take these design plans and you code it so that the user interface grows from stage to stage. So here's a new wireframe. This is for the login page. Let's code that. You're developing that. Here's the login page, not the login page, the dashboard after you log in. And so you code things and you're sort of moving the website along. You're developing it. You're moving it forward. And you're always progressing and developing things. Of course, I'm not excluding a lot of other things, because a UI developer or web developer also is sometimes the designer, and also is sometimes a UX professional, also is sometimes, the CTO or whatever the case is. You could wear lots of hats, but we're talking about specifically when you put your hat on. I'm a web developer right now. I'm developing the website. So what is a program? A program, this is the etymology. This is sort of interesting things coming from the etymology of the word program. So in Greek, it's an edict or a proclamation. In 1837, we have a definite plan or scheme, a method of operation, a line of procedure prepared or announced beforehand. You can think of this also like a recipe. So whenever you have a recipe, it says, do this, do this, do this, use these amounts. If you're making 2 servings, then double this, but if you're making 2 servings, just put 1.5 times or 75% of this other thing, whatever the case is. if you're cutting it down to half serving. There's all these different calculations you can do, but it's like the scheme or the procedure to prepare something. So in the computer sense, since 1945, a series of coded instructions which directs the computer in carrying out a specific task. So a program, pretty much what we think about it, but let's break it down into its smallest parts, that it's a series of instructions, essentially. A series of coded instructions. So more than one code, so instead of x plus 2, you might even consider that 2 codes, we're going to have more than one code. It's no longer just a code, and we're not just saying, let's just see some information. We are returning some sort of function. If you recognize that this is and now I broke myself. The Fibonacci equation. So to be interpreted by computer's instructions. So a program is more than one code. It's a series of codes that are related to the same type of thing. So programming is the act of using a programming language, and I can't tell if that's bold or not. Programming language is bold down here. A Turing-complete set of codes. So using a programming language to write that series of related codes. So a program at a theater isn't using a programming language, and it's not a series of instructions toward a computer. It's still a program. But programming in software engineering and architecture, that's what SEA is codes that a computer can use as instructions written in a programming language. So there's a lot of other things out there that aren't programming languages, and so we wouldn't call it programming. We would just keep it sort of coding. It's one of those things where is a seat a chair, or is a chair a seat, that all of these things are coding, but not all of these things are programming, because if you could be coding, like I said, a lot of other things, a lot of data entry, and even just pure HTML, for example. I'm not saying that's all web developers do, but if you're doing just pure HTML, you're not programming, you're coding. But if you're also doing backend and all that sort of stuff, we're not going to go into that right now. But programming requires that you're using a Turing-complete programming language. And once again, from the beginning, this is the ubiquitous language that we're going to be using in all of the things related to the videos moving forward. So feel free to use this as your official, to adopt this as your official usage of these terms, or feel free to jump into the Techlahoma Slack and message me and join these conversations, and let's come up with other ideas for inclusion and stuff like that. So what is program development? This probably looks very similar to the very last one. So it's the act of taking engineered plans and programming such that the program grows from stage to stage. So a lot like web development, but in this case, instead of, or UI development, instead of just using XML or HTML or some sort of user interface to generate another user interface, we're talking about building a program. So the main difference here is programming, the word programming, that we're now using programming language instead of just coding. And like I said, programmers can also be web developers. They can also be software developers. Data science is a big one that I would say is programmers. And I'm going to get into other things here in a second, but programming has a lot to do with those lower level implementations. Really good at algorithms, really good at putting in stuff for the lower level portions of software. So what is software? This is an interesting thing that I found. It's not the highest voted thing, but it's an interesting answer that I found. I sort of fixed it a little bit and altered it a little bit. So this is like a regular expression type thing that I put in here in order to communicate to you this idea. If you have a character, and plus sign in regular expressions means one or more. So if you have a character, one or more characters, then you have a word. So A is a word and I is a word. Also, word is a word. So a character, one or more characters a word, one or more words a statement, one or more statements is a program, and one or more programs is software. So this is like a really cool, interesting way of looking at what is software. I altered it to have this regular expression because software could just be one program. You've written one program. That one program has one statement in it. It has one word in it. It has one character. Just return empty or whatever the case is. It's not very good software. It's not very useful. But software is sort of like the collection of programs. So a program might be a microservice or a website or something like that. But all those pieces together, all the dependencies coming together and working together, that is software. Because you can individually deploy a microservice. but it has dependencies on FedEx or UPS. It has dependencies on whatever third parties, Google and Facebook and whatnot. But when you put those programs together, then they make software. My face is covering the slide. Oh, it's covering part of the last slide. Gotcha. It just says "and more" underneath that last slide. But yeah, thank you for pointing that out. Okay, so what is software development? So we're changing from program development and further away from coding and stuff like that. So software development is the same thing. We're just still doing programming, but it's to make sure the software grows. And like I mentioned, software is a collection of programs. So when you're programming something related to software, you're calling yourself a software developer. You're no longer just thinking about that domain, that single domain of a program where you're writing the algorithms for this one thing, payment processing or whatever the case is. When you're doing software development, you're also taking in all these third-party things, these SDKs, these other APIs, calling up to the database. You're taking in a lot more than just programming. So if you just purely say you're a programmer, you're not a software developer, you might be someone like data science. I'm not saying all data science is purely focused, not touching database and stuff like that. But if you're purely taking in data and building models and just doing these algorithms, you're doing purely functional development, then you're probably a programmer. And so that's programming. But software development is when you're also hitting a database and you're also calling out the third-party things, and you're interacting with these multiple different programs, different layers and stuff like that. So software development is slightly different than programming. I'm a programmer versus I'm a software developer. So these are pretty minute distinctions, and feel free to jump into our. And again, we're just missing the word sometimes. There's nothing really missing where my face is here. I can even remove it for a little bit. So what is engineering? Engineering is now moving up to the next level. It's no longer talking about coding. It's no longer talking about really doing necessarily. So engineering is more about planning. It's more about understanding the systems, the complex products. And most importantly, it's using scientific and mathematical principles. So the word principles being a very important one, scientific and mathematical. These are very important things that I sort of talked about this in one of my talks a couple weeks ago. What are principles? What are values? What are best practices and things like that? That engineering is no longer just doing coding, no longer just programming. It's programming with principles. Now the engineer. I had this little slide right here. So it's no longer this development mentality. It's no longer just moving a plan from stage to stage. That software engineering is planning the development of software by understanding the scientific and mathematical principles. And most software engineers, I'll point to down here, wear multiple hats. So a lot of times, most of the time even, software engineers are also the software developers. So if you are just a developer, you're probably taking stories and tasks and whatnot and following plans and following the patterns of the current systems and doing some programming and implementing things. You're just a software developer. You don't really think about the high level principles and things like that. You sort of wait for your pull request to go through, and then the software engineer to say, well, can you please, abstract this, or can you please, do something else? But the software engineer, if you're a software engineer who's doing development, the software engineer doesn't just know of the principles and doesn't just, a software developer may just know of the principles and may or may not know why or how. But the software engineer doesn't just know about the principles, but always employs principles. Once you're a software engineer level, you're at the level that you haven't just heard of things, you also practice those things. There's a really cool quote that I heard a long time ago that you're great at something if you practice until you get it right, but you're a master at something when you practice so much that you can't get it wrong. Not to say that software engineers are infallible and they can't get things wrong, but you get to that level where not only do you know of the things, you also always observe those things. And I don't want to get into when to know whether or not to use patterns and principles and things like that, because an engineer would know those things. It's a very long talk, but that's the difference between software engineering and development. All right, so does software engineering include coding? So software engineering is all about planning, observing principles and stuff like that. It does not directly involve coding. So like I said, software engineers are usually also the developers, not the developers, but part of the development team. So in a sense, yes, software engineering does involve coding. Does coding include software engineering? This is where I get this quote here in the description of the video, that is a seat a chair. Sometimes coding includes software engineering, but most often no, because anywhere can be a seat. Your anatomy may be called a seat, your butt's a seat. But coding is a huge world. There's a lot to do with coding. There's, all this stuff that I was talking about before. You could be a coder and not necessarily be software engineering. So it's the same thing in casual conversation. So I might actually go around telling people I'm a coder. I actually have done that multiple times in my life. Because if someone asks what I do, I don't want to get into this whole talk. I might link them to this talk from now on. I don't know, but I just say coder in casual conversation. It's not that big deal. It's like saying I'm going to the dentist. That's such a generic word. They're actually probably going to an orthodontic surgeon or whatever the case is. So some coding does include software engineering. So yeah, this question: what if ChatGPT writes your code for you? Can you still be a software engineer? No, absolutely not. That's not the same thing. Is a software dev better than a programmer? So if you're a software developer, does that mean you're better than a programmer? Like you're more advanced than a programmer? All that sort of stuff. So no, programming, as I was trying to talk about before, if you're a programmer, you write purely functional code, you're data science or whatever the case is, you're doing a lot of stuff that isn't necessarily software development, and that a software development might not even know. And as a pure programmer who focuses on something hardcore, like really fast algorithms and things like that, really functional code, and that's what your focus is, not software development, but programming, you could make much more than a lot of software developers. It goes back and forth. Now, in order to be a software developer, you have to be a programmer, because you do programming to accomplish creating software. But in order to be a programmer, you don't have to be a software developer. So there is an upward direction from going from programmer to software developer, but it doesn't make them better. It doesn't make a software developer a better programmer. It just makes a software developer focused on the interconnectivity of systems and things like that. It does not mean that they're better. Same thing with like web developer. And this is more along the line of coding. So if you're a web developer, and not just coding, but also programming, let's say JavaScript, stuff like that, you have to deal with integrations of media, users, devices, UI stuff. There's a lot to that me, as a software developer or engineer, I don't want to have to deal with that stuff. I don't want to go into the website and focus on all integration stuff. Dealing with people, user experience, and all that sort of stuff, delivering these things, I just absolutely cannot. I do not want to do that. I'm not better than you. You deal with a completely different thing than I do. So yeah, this is all the stuff that I just talked about. It's not better than, it's just different. Is a surgeon better than a physician? This is sort of just following the same lines as an example. So no, physicians work with people. Physicians know more about specialized medicines, and they try to focus on external methods to try to heal people or self-healing. Surgeons just don't work with people at the same level. They don't work long-term as a primary care physician, for example. But they do focus on treating illness directly with surgery. One's not better than the other. They're just completely different jobs. And granted, along the same lines as I said before, you're a physician before becoming a surgeon. On your path to being a surgeon, you spend some time as an intern physician learning about the doctor, learning about patients, learning about the general idea of being a physician. I'm not going to say that's the same thing for everywhere, but that's just sort of the idea of becoming a surgeon. Okay, so I sort of talked about this a little bit when I said, I'm going to go to the dentist. I'm going to. You're not specifying exactly what you are in casual conversation, but you're saying something like I am a doctor is like saying I'm a coder or I'm a programmer. It's sort of the same type of thing. You can say that, but there's a lot more to it than that probably. So a coder or programmer may receive a solid amount of education, but a software engineer takes extra time, just like the surgeon did, extra time beyond becoming a physician, extra time to educate themselves or gain education with experience, residency of being a software developer for a long time, and then additionally to learn why. So a developer asks, how do I implement this pattern? An engineer asks, why do I implement this pattern? Actually, an engineer doesn't ask that. A developer starts to ask, why do I implement this pattern on their path to becoming an engineer? And an engineer already sort of knows the answers to those questions. I'm just looking over at questions. Yes, a lot of chat about ChatGPT, obviously. So yeah, now hiring. A company is looking for somebody who can fix their website. It isn't working because it isn't working the same for their user base who mainly uses Chrome versus their user base who mainly uses the iOS app. This is sort of like a riddle, you might say. Like, okay, look at this. This is their problem. If a company went to a recruiting agency and said, you know, this is what's wrong, this is the type of thing we need, then a good recruiting company might say something like, you need a web and mobile developer, and they need a couple years of experience and could maintain an okay rate. You know, that whatever the rate or salary, it's going to be pretty good because they have these integrations, experience with iOS, experience with React or Angular or whatever it is for the Chrome, for the web development. So looking for, this is like the job posting, looking for a web and mobile developer with 2+ years of experience with iOS and web, and the pay is 100. That's not $100 an hour or 100K. Just imagine 100 is like the right amount for a web developer who also does mobile development, web and mobile development. So 100, perfect. So yeah, this is a pretty good job posting. You don't need somebody with 10 years of experience to come in and try to fix this thing that's getting out of sync between the possibly with the UI in something that's on the iOS app and on the web application. So yeah, okay, this is a pretty basic thing for a web and mobile developer. Pretty cool, no big deal. All right, so we're going to get into this other now hiring. Looking for a junior software engineer with 2+ years of experience with iOS and web, pay 60. So these people, the recruiters who created this job posting did not do a good job, or maybe not even recruiters, the hiring managers, the HR department, whatever the case is, they did not do a good job with this. So 60. So 60, we don't know what that is. It's not per hour. It's not K. It's not anything like that. But let's say 60 it's fine for a 2+ year developer, but for an engineer, it's pretty low. You know, no big deal. Except they said they're looking for a software engineer and a junior software engineer with 2 years of experience. So this is where we start to get why this is important, because this could be toxic. This could be something that you want to be on the lookout for whenever you see this type of thing. And maybe you don't just turn it down, but maybe you ask them in the interview, or maybe you talk to the recruiter or the hiring manager before you schedule an interview. You say, you know, what do you really mean by this? Because maybe you don't know, or maybe you know and you're just trying to scam me a little bit here. This is pretty important. So yeah, this is like asking for a novice surgeon. Like I said there in the beginning of the talk, that you can't get a novice surgeon. You can't get a junior software engineer. There's no such thing. There is a possibility that if you ask for a software engineer with 2+ years of experience, you mean somebody who's been a software developer for, let's say, 5, 6, 7 years or whatever the case is, and they've officially, for the last 2 years, started calling themselves a software engineer. But if that's really what they're looking for, they wouldn't have put junior, and they wouldn't be paying 60, whatever 60 happens to be in your language. They wouldn't be paying for somebody with 2 years of experience for somebody who really has 7 years of experience or whatever the case is. So it's toxic. It could be toxic for 2 reasons. There's 2 different reasons why this job posting got up there. So one is the employer doesn't know. So I'm going to give them the benefit of the doubt. The employer does not know what they need. They don't have a technical team necessarily. They have a CEO, and the CEO says, "Hey, people, go hire us a person to fix our app. You know, we paid for this app and this web application and iOS application from some other place. That place closed," or whatever the case is. We need somebody to come in on staff and fix this thing. So the problem is, if they put this thing up there, then their lack of leadership, if they're really looking for a junior person, let's say, they're looking for a junior person, and because they said the word junior and they paid you low, but they know the word software engineer. So somebody told them you need a software engineer, and they came to the conclusion that they just need a novice. So they said novice software engineer. So without their leadership or their understanding of what they need, they're just coming to you to essentially run their new system because they don't know any better. You're going to make mistakes and you may get fired. No big deal, whatever. Even worse than that, is being praised for completing the task. So let's say you jump in there and you hack your way through because you've been a developer for a year or two and you sort of know what you're doing a little bit, and you jump in the iOS and you do some bad practices because you're not a software engineer. You haven't been doing this for 10 years or 5 or whatever your number is. So then that ingrains bad practices in you. Either way, if somebody's looking for a junior software engineer with 2 years of experience, it's going to create a toxic atmosphere for you. It's not somewhere that you want to go. You want to go somewhere as a junior who has good leadership, and where they're not going to be calling you their senior engineer or their full stack engineer or anything like that. Because if you have 1 or 2 years of experience, a little bit out of college or whatever the case is, you don't want to go somewhere where they're putting a title on you for something that is not what you do. So if you're a physician and you go to a hospital and they say, hey, you're our new head of surgery, that's not going to end well for anybody. The other side of that, 60 means bananas, 60 bananas. So the other side of that is the employer does know. So previously I gave them the benefit of the doubt. In this case, I'm saying they do know. Let's reread that job requirement. So I posted it here again. Their user base who mainly uses Chrome versus their user base who mainly uses the iOS app. This isn't saying Chrome's the problem or iOS is the problem or there's some sort of mismatch between there. It's talking about the types of people that use Chrome versus the types of people that use iOS. The types of people who use iOS, I don't want to get into that, but they're also using Chrome probably, on some other machine or some work machine. But it's not iOS that's the problem. It's that the way they use it is in the way that they expect iOS type stuff to work. So it's more of a mentality between these people, which means that there's something deeper in the system, something deeper going on with the architecture of the system because of the different ways that people use it. It's like a different mentality. And the employer knows this. Like they've been working on this for a while. They already have a bunch of, let's say, junior-ish or mid-level professionals that are working on these things, and they can't quite figure out how to do this architecture. They can't figure out how to do the software engineering in order to make it work with 2 different types of mentalities of people, 2 different audiences using their software. So they know that they should be hiring a software engineer to come fix their stuff, or even a software architect, but I don't get into that in this talk. And they should be paying them 120 bananas, whatever the case is, 120 bananas for a software engineer. But they don't want to. They want to underpay and overwork a web developer or a programmer or whatever the case is, and they hope that they get lucky and figure something out. So they're going to hire a junior person. They're going to put them in this position where they better fix something that's way more complex, an engineering level problem, and so either way, whether they know or not, either way, this is going to be a toxic situation. Let's move on to a code versus a software engineer. So the reason why this talk is so important, and to say this is what programming is, this is what software engineering is, this is what coding is, all that sort of stuff, is because we need. It's not because we need a different understanding of what level you are. Oh, you're a coder, you're lower level than I am as a software engineer. They're 2 different things. They're completely different things. A programmer is working with algorithms and lower level things, and a software developer is working with system integration. They're different types of stuff that's going on. The reason is because we're all professionals in the IT industry, and we should be treated as such. So, sure, casually speaking, call me a dentist. If someone says, I hired myself a dentist to fix our website, in this case, or maybe something like a web developer, or I hired a coder to come and work for us, that's perfectly fine in casual conversation. But we don't want to see things like this. Looking for a software engineer with 2+ years of experience and deep knowledge of principles and database design and agile process and stuff like that. Software engineer, perfect. Knowing principles, perfect. Paying up to 100, perfect. 2 years of experience, that's not aligning. You're taking somebody who's new to the industry. They don't know what software engineer necessarily means. Like, I know OO. I've seen a database. Agile, I've heard of that. Oh, they only need 2 years of experience. Obviously, I'd be a good fit for that. I have exactly 2 years of experience. Paying up to 100. Oh, heck yeah, I'm going to take that. 100 bananas. I love me some bananas. So 2 years of experience. This is really throwing people off. Now, if what they really mean here is a software engineer who's been a developer for 5 years or more, or whatever the case is, and they've been calling themselves for 2 years, calling themselves a software engineer, then that sort of makes sense. But you have to be really careful with these types of things. It's very important because you don't want to enter into a toxic environment with toxic hiring managers and things like that.